Welcome to CE Voices, a series of interviews brought to you by Chemical Engineering. These insightful conversations cover a broad range of topics that are of interest to professionals in the chemical process industries.
Hello, everyone. I'm Scott Jenkins, the senior editor at Chemical Engineering magazine. We're here with another edition of the CE Voices series. It's our new video series that we've been doing. Our guest today is Steven Jenkins. Just for the record, we're not related as far as we know. But Steven is the vice president for chemicals and polymers at Wood Mackenzie for the Asia Pacific region. Steven has recently written an opinion piece on the movement toward the circular economy. And so we thought it would be interesting to ask him a few things about the piece and get some perspective from him. So Steven, thank you so much for joining us.
Yeah, no problem, Scott. Really nice to be here.
Great. So we're going to start out just, I know probably everyone has seen an overall renewed interest in sustainability around a lot of different industries. Especially moving into oil and gas and petrochemicals recently. And so just to start out, what factors do you think have played a role in how the oil, gas, polymers, refining sectors are looking at this issue?
I think you can't have any discussion on this sort of stuff without carbon dioxide, global warming, really sitting there, I guess, as the primary mover. I mean, there's so much complexity in all of the environmental issues that focus tends to come into one thing. And clearly, over the last 10, 15 years, it's been global warming, CO2, whether you see that in environmental programs, ice melting, people being able to circumnavigate the North Pole because there's no summer ice and so on. And therefore, that's pushed the agenda really around decarbonization for a lot of companies. So you're looking at, BP committing to decarbonization by 2050. So really, I think that is the kind of totem for focus on the environment from the oil and gas refining sector. And from that awareness has then cascaded through a whole bunch of other environmental initiatives.
Mm-hmm. So in the recent piece that you wrote, you described the current efforts towards sustainability as being in isolated spheres for each company. And I was wondering if you could just help us understand that a little better and sort of outline what problems arise with that kind of approach.
Yeah, and I think part of it stems from the what we all understand by sustainability or circularity, because sustainability really is, that's looking much wider. That's looking at the environment, the economy, and society together, and the goals of that are much more diffuse than, say, the circular economy, which is very focused on specific processes and specific companies and what they can do within this. So I think number one, it's important to distinguish between chasing or aspiring to sustainability versus the application of circularity in an economy. And therefore, you get a lot of, or what appears to be a lot of public comment or public action by a range of people across the value chain, everything from refiners, producers, gas producers, all the way through manufacturers, retailers, brand owners, and so on. And they're all doing their bit, and some of them are doing it very well, and the initiatives that are coming through are great. Others are kind of hiding behind membership of industry associations and, putting a little bit of money in to give the illusion that they're actually doing something meaningful. And a good example of that would be It's a very major polymer producer. And you look at what they're doing, you look onto their website and stuff, and they'll say, we're developing this polymer or that polymer to tackle the problems of sustainability and circularity, and this will allow packaging to be more easily recycled.
Mm-hmm.
And that's great, but they're doing it for them. It's not, they may come up with a grade of something that they can then sell and make money from, and patent the technology. But it's kind of like, where's the sharing? Is this tackling the problem? And maybe your audience are familiar with root cause analysis. These all the way through the chemical and the oil and gas industry, there's some very clever people. It's an industry that's dominated by safety, all of that type of stuff. And therefore, when things go wrong, you have root cause analysis straight away. And you look and say, what's the cause of the problem? What can we do to fix it and make sure this never happens again? But within the whole sustainability, circularity issue, there's very much, well, let's ignore the problem, but let's come up with some solutions that will make us look like the good guys. So you have pockets of excellence in technology development, in product development, and in actually initiatives further downstream to manage plastic waste. But there's no overall framework, or certainly no overall voluntary framework to pull all of that together.
So the other story that you shared in the piece had to do with the manufacture of plastic toothpaste tubes, and involved some sharing of intellectual property. And I was wondering if you could explain that example and see if that's a way, an example of how things might work better in the future.
Yeah, that kind of neatly kind of brings in, some of the things I was saying before, which is to move it forward, you have to address a number of different problems. And the one that came up was Colgate. And Colgate, they make toothpaste. There are other oral care brands available, I guess we should say. But when you make a toothpaste tube, if you say, what's the biggest problem with a toothpaste tube? I'd say you can't get the last little bit out of the bottom, and I think everybody knows what that is. But that's because toothpaste tubes, you roll them up. There are some pump ones, but generally they're the kind of laminated HDPE around kind of core of aluminum. So that's a nightmare to recycle. And just in general, one of the reasons you have very low recycling rates of polyethylene, for example, is because they go into so many laminated products. So the same with PP, I guess. And it's that mix of materials that makes it very difficult for recyclers to deal with. So Colgate actually worked a solution, which is to come up, instead of having different grades of HDPE and the aluminum, to come up with one specific grade that was flexible enough, that did everything a toothpaste tube should do. And then they released the IP, public. A bit like if you're developing a Linux program or something online, there's an open source community, and they said, look, here's what we've done. This is going to solve a problem, which is great, except as far as I can see, none of their competitors have picked it up. And this then leads into, why not? There's a solution, but the commercial reality is that in the really dog-eat-dog world of brand management and market share, how is a major going to adopt technology from another major, even if it's for good, without some, I won't say loss of brand reputation, but it just doesn't feel comfortable, I guess, if you're the brand manager of somewhere else, to say, yeah, and we're adopting this. So there needs to be a little bit more of an open mindset to say, hey, this is best practice. Let's move let's move forward.
Yeah. So in the production of petroleum-based fuels and chemicals, including plastics, there's obviously a huge level of capital assets already in play. And I guess the question is, how should we start thinking about issues of circularity in relation to all the existing capital assets that are in place already?
Yeah, I mean, I haven't done the calculation, but if if somebody was to do it, how many trillions of dollars are sitting in the ground operating today? It's a lot. There's a big installed infrastructure there. But again, if you kind of step back and say, okay, the world is not going to do without, let's say, plastic packaging. Plastic packaging has many advantages, as even its fiercest critics will probably admit to. So the other thing is, you can't change chemistry. As long as people have been trying to turn lead to gold, you can't you can't change chemistry. So therefore, if you want some sort of sustainability in polyethylene, you're going to need to make ethylene. And so the issue then is, how do you best use the assets that are there? And the assets that are there kind of shape the technology that's being developed. So, if you're looking at bioaromatics, for example, from crop waste, you can do enzymatic digestion of cellulose to make a bioreformate, which you can then feed into a BTX splitter and get out the xylene that you need for paraxylene to make polyester.
Right.
Same with bioethanol. And today you get bioethanol dehydrated to ethylene to make monoethylene glycol. And that bio-MEG is used in products that claim and say, we are green products because a part of the molecule is bio-derived MEG. So the chemistry doesn't change. It's the approach as to how do you collect the waste, how do you manage the resources that are then going to make the chemical feedstocks that you want. Now, clearly, there may be some new biopolymers on the horizon, but generally, with those types of products, if they were so good, they'd already be world leaders. And generally, the alternate polymers that are coming through are either more expensive or don't perform quite as well in the design that you have. So therefore, if you want to go down that route, you have to redesign the packaging or you redesign the application. But ultimately, you're still working with chemistry. So that installed base is part of the solution to really drive circularity and sustainability.
Yeah, that's a good point there. So, in the article or the piece that you wrote, you also mentioned that there can be trade-offs between kind of these circular approaches to things and the efficiencies that you might be able to achieve. So, can you explain a little more about what you meant by that, and maybe if there's an example you could point to illustrate?
It's quite often what we've seen in a lot of the work we've done is that the good intention to move from bad product A to good product B, taken in isolation, would seem the right thing to do. But when you actually dig into it and you start looking either at life cycle analysis or different aspects of the manufacturing process, you suddenly come to the conclusion that actually you're solving a problem here, but you're creating a bigger problem somewhere else. Electric vehicles, if people are worried about emissions, then the move to EVs or hybrid EVs is, a great thing to do. But if the power that you're getting to drive those EVs is coming, let's say, from coal, then actually the emissions that are associated with that are probably not so great. From a chemical point of view, again, I come back to things like some of the biopolymers, some of the processes for converting cellulose or carbohydrates through into biopolymers are quite difficult. You look at either power usage, water usage, land usage. And if you're looking at land and even crop waste, you're looking then at desertification. Are you looking at water usage? Are you looking at pesticide usage? A lot of different kind of areas that you would just say it's like a balloon full of water. You push at one part and a little bubble pops out somewhere else. So you have to have a balanced scorecard approach to say which is just the least bad solution. And therefore things, for example, like pyrolysis. Pyrolysis has been studied for a long time. And if you look at the problem of mixed plastic waste, and like I said, if you look at polyester gets recycled at the rate of kind of 45 to 50% of all the PET that's made in the world actually gets recycled. Why? Because PET bottles are basically pure monomaterials. You know, the design process now, you have a sleeve label which can come off, you've got polypropylene top which you can chop off, and the rest of it is pure PET. But where you've got mixed polymers, HDPE, LDPE, PP, and as we said in the toothpaste example, you know, that's mixed in with aluminum. How do you manage that? You know, and the rate of recycling there is probably less than 5%. Maybe you just throw it into a big oven, you know, and you cook it, you make your pyrolysis oil, and then you put that into a cracker or whatever. However, when you're running furnaces at 500, 600, 700 degrees C, there are going to be emissions associated with that. There's going to be some waste product that needs treated associated with that. Is that what we want, or do you just want 95% of your polyolefin waste to be going to landfill, incineration, or, you know, leak into the environment? So people need to understand you can't just make a good choice and assume there are no consequences. You have to think much broader as to what problem you're trying to tackle and how you want to tackle that.
Right. Another thing that came up in the piece was the Montreal Protocol. So listeners of a certain age may remember this from a couple decades ago, regarding the banning of ozone depleting chemicals. And we're wondering if you could just remind us of what occurred there, and how might that situation provide some lessons for the current situation of addressing single-use plastic waste.
Yeah, I love your comment. Viewers of a certain age. I am of that certain age. I was living through that. I was actually working through that because I was involved in the development of HFCs. Actually based in the US at the time, and helping the transition from CFCs to HFCs. The Montreal Protocol basically came about because the ozone layer above the Antarctic was depleting. Why does that matter? Well, the ozone layer stops ultraviolet light getting through to the planet. And if we want a nice sterile rock to live on, get rid of the ozone, and you have it. So all those harmful UV rays that we slap sun cream on to protect, even with a good ozone layer, the issue was chlorofluorocarbons were implicated in the mechanisms for depleting ozone. And this was a real problem. And actually, the world got together. You know, it was a clear problem, and the Montreal Protocol was signed. Action was taken globally. I mean, some countries it took a little bit longer than others, but there was basically action at a global level. And CFCs were phased out, hydrofluorocarbons were phased in, and that came with a host of problems, because without boring viewers of a certain age, chlorine is a great extreme pressure additive. And when you're running a mixture of CFC through compressors, the chlorine basically acts as an anti-wear additive and so on. And they found that when you took chlorine out, all the compressors were seizing. So your HVAC, mobile air conditioning, your hermetic compressor in your domestic fridge would just seize up. The motors in little hermetic compressors, when the wire is drawn to wrap around to make the motor, has an infinitesimal amount of paraffin wax to draw the oil, and that was being dissolved by the HFCs and being deposited in capillary tubes and blocking up fridges within a week. So there was a lot of engineering then that went on with the new chemicals to get them in place. But the point is, there was a clear problem. Everybody got together. They addressed it with common action. There were common rules. Everybody played by that. Now you come to the current climate crisis, as it's been named, and you have the Paris Accord, for example, which seeks to try and reduce CO2 emissions, or at least cap them at certain levels. Yet it's extremely unhelpful when people walk away from that, or cite national interest. And certainly, that's, I guess, clear, because people who don't want to adopt these types of rules as quickly also cite national interest. But without concerted effort, really at a national level or a legislative level, you tend not to get real meaningful action. And I think the problem we see now with polymer waste is everybody's waiting for the legislation. It's kind of, we'll do our bit to show that we're good, but actually we're just really waiting for the legislation. So in Europe, for example, there's the European directive on recycling that's coming in, which will mandate a minimum level of recycled material in packaging, and that increases over time. And that's going to have implications for producers along many value chains all around the world. So if you're in China and you're manufacturing toys or hair dryers or toothbrushes or whatever it is, the packaging that's going to be wrapped up in, that you then export to the US or certainly into Europe, it's going to have a recycled content. So the very fact that the world have so many multinational corporations and that you have such a geographically diverse manufacturing chain, and we've seen that obviously during the pandemic, that those chains have in some cases broken. You can't get a road bike for love or money, because the entire value chain there kind of stopped for a while. But when you have either a country or a state, and California obviously leads in some of these areas as well, everybody then has to play to the highest rule. Because of that complexity, you're not just going to have one grade of toy that you can sell in Europe, and then you're going to sell something else kind of elsewhere. I think legislation or taxation or a combination of the two, it's not so much carrot and stick. I think there's going to be a lot more stick than there is carrot. But there certainly needs to be both.
Right. So before we sign off, do you have any final thoughts about the need for collaboration and coordination among industry stakeholders in order to make progress on these issues?
It's a little bit of motherhood and apple pie statement, but really there needs to be just a broader way of looking at the problem. And I think if we focus, on chemical companies, not only do they need to look up and down the value chains, they need to look across the value chain. So, instead of drilling for oil and gas and, looking at that as feedstock, you're starting to talk to some of the big waste management companies, because that is going to be a feedstock. You talk to some of the big agricultural traders who manage huge flows of agricultural goods, because they too will have access or a network that could feed agriculture and crop waste into the system. So there has to be much more of a matrix, looking vertically, looking horizontally, and even into a kind of like a third dimension, through time, as to how you work. And sadly, capitalism works against that. The stock market and to a point, shareholders work against that, because the amount of R&D, the amount of capex that you need to develop some of these initiatives kind of goes against the, well, let's grow EBITDA by 3% this year and increase the dividend and so on. So unless it goes hand in hand with, for example, the government saying, well, you can write off this amount of IP as, a tax credit. We will give you tax credit for developing these things, or putting carbon taxes or whatever on some areas, but funneling the money back into proper research and proper investment. Basically, the system has to change, and at the moment, it tends to be driven by self-interest, and that's a financial imperative, for the majority of companies, certainly in the West, that are not either family-owned or not listed. So it's kind of everybody's responsibility to find a system to work together. And like I said earlier, individual companies are doing some great things. It's just they need to join the dots in probably a more coherent way, and get a lot more stakeholder involvement across a much wider range of area. And it's not going to be quick. So focus on the quick wins. They may be quick and dirty, but if they move everybody in the right direction, it's better than doing nothing.
Right. All right, well, we're going to leave it there for now. I'd like to thank Steven Jenkins from Wood Mackenzie again for joining us and providing all the perspective and insight that we've heard. So with that, I'm Scott Jenkins and signing off for now for CE Voices, and we'll see you next time.